Okay, here we are. This is called an orrery. And I've had this for, I don't know, probably 8 years. 8 years, I think. And what this is a representation of the solar system. And this white spinning ball here, sorry to the flat earth people, is Earth. And that's the moon going around it. And of course, the center, this brass ball at the center, is the sun. And each of these move, though you can't see its very small movement on the outer ones, because they move a lot slower. But each of these is moving. And then this kind of works like a clock. So you can see here is Mercury. This is Venus, Earth, and the moon. This is Jupiter out here. And, oh, sorry, this one's Jupiter, and this one's Saturn. I'm gonna move this over a little bit for you. There you go, you can see Saturn, and you can see Jupiter right there. And historically, there were only 4 major moons known for Jupiter. But of course, we learned that there's many, many more now. And Saturn had a few more known to the world. Now, how old do you think this thing is? So for those of you that are on Facebook, you might be able to see right here at the top of this thing. If we kind of turn it this way, you might be able to see it here. Who it's made by. I'll move this a little bit. And it's made by Newton and Company right here. So it's funny, when I bought this, I had no idea who made it. I just thought it looked super cool. And I bought it at an auction. And I had no idea, of its importance or anything. You can see here that it has an astrological calendar on it, and English, it's written in English as well. So May over here, May, June, July, August, and then it's Taurus and all the other zodiacal signs. And this particular model is from the early 18th century, around 1704. And Isaac Newton had started a company, an optics company, that was called Newton and Co. And it was on Fleet Street. And this was one of the first orreries that came out of that. There was like microscopes and all kinds of other stuff that Sir Isaac Newton had kind of innovated and made. Although he wasn't the one who to create the first orreries or anything like that. Orreries are like clocks. They're like watches with sophisticated movements. So you can see, and I kind of used to collect watches. I don't anymore. I just wear a regular digital watch now. But I used to collect watches because I liked the mechanism and what's called the complication of it. But this has really stuck with me because, I don't know, it kind of represented the order of the universe to me. And yesterday, we talked a lot about the Vesica piscis and how the Vesica really represents the order of the universe. It also represents the foundational basis of the flower of life. And so we're going to talk a little bit more about that order today and exactly how the flower of life creates virtually everything around us. So we put this away. And here we go. And the sun has changed its position somewhat, so that's why it's been harder to see some of my notes and everything, particularly for the people on the Instagram account. I don't have, and I don't want to have, curtains in my office, and there's like a double ceiling in here because this is a 2-floor library. And as such, the light comes in here kind of strangely sometimes, and it can kind of mess things up for when I want to present to you guys. But I didn't ever think I'd be doing presentations in here to anybody, so I didn't really think through having to put curtains in and stuff like that, but I like the light in here in general. So I'll come back to this in a moment. Okay. And this is something I drew just this morning. And it is the Vesica again. And make sure the guys on Facebook can see this. Yeah, you can see it great. Okay. I'll move it a little bit this way for you. Okay. So again, for the people that want to be able to see this really well, rather than look at me, which I'm sure most people would rather see this than look at me, you can go on to Facebook and have a look at what's on Facebook, and you'll be able to see the detail of this, because this camera right here, just is a little bit above what you guys can see, is got a close-up image on this, so you can see everything perfectly. Some people are actually watching both at the same time, because they may have a computer and where they're accessing Facebook and they've got their iPhone or whatever, and they're watching the Instagram live broadcast. But basically what I drew this morning was the Vesica, and out of the Vesica, so the Vesica is these two circles right here, the black circles. All right, so this circle that goes just like this, around here, and then the same, the other side of the Vesica is right along here, and here is the Vesica. And someone asked me yesterday if this Vesica shape is also an eye, and the answer is yes, it is, definitely. In fact, it has an eye that you can see in 2 dimensions of this, so X and Y axis. So you've got, on the Y axis, you've got this vertical Vesica, and on the X axis, you've got a horizontal Vesica. So 2 eyes kind of overlapping each other at a perpendicular line here at the center. And what I started doing here is seeing if I could find even more and more numbers that I hadn't seen before. And what I found is that you can find all 13 of the numbers inside the first round of the Flower of Life. And then once you go out to the next round of the Flower of Life, it gives you the next octave. So it gives you kind of 12 plus 1. So there's actually a total of 14, I guess. And this, again, relates to musical notes and the way musical notes work, which there are actually 14 inside of an octave, but 2 of them are what I call gap notes. So you're actually only ending up with 12 notes in an octave. And that's why 24 and 24 become really important. But as you move around to where there's polarity shifts at each of the cardinal 4 points on a Cartesian plane, then you'll find that there's a gap note right before switching polarities at each of those points, at 90 degrees, at 180 degrees, at 270, and then again at 360. And that's just an octave of music kind of going around. But I measured all of these to make sure everything was accurate, and sure, it was. You can find inside here the square root of 1, which is the radius, the square root of 2, the square root of 3, the square root of 4, the square root, so 4, the square root of 5, sitting inside here. Square root of 6 is also in here, right here. 7, 8, 9, 10, 11, 12, 13, and 14, all inside just this one little space in here. And what was amazing to me is how orderly all of that really is. It's kind of shocking, in fact. So, what I wanted to show you next was how these waves actually go beyond just what we're talking about with numbers and extend all the way into, not only numbers and musical notes, but mathematical constants. And they also extend even to the periodic table of elements that you might remember from chemistry class. And certain frequencies that associate with those periodic table of elements, or periodic wave of elements, probably as they should be called. So what this is mathematical constants. So the same thing as the Vesica is being formed here, and we're actually creating numbers 1 through 12 along this. And what's happening here is that, and I made this a few years ago, and this became a subject of a paper. If you're interested in reading the paper is called The Wave Theory of Numbers and the Wave Theory of Constants. So you see the way these waves overlap with each other, right? Because this is like a sine-cosine wave. It's like DNA also, as you can see here at the bottom of the page. Hopefully you guys from Facebook can see it too. Yep. What they're seeing here is that at each of these nodal points, that there are mathematical constants that emerge off of it, where each of these waves overlap and intersect. They create math constants like phi, like pi, like alpha Euler, phi squared, square root of phi, all of these different mathematical constants. And then on one side, I've got their x over 1 value, and then on the bottom side, it's the 1 over x value. So for example, the 1 over x for the square root of 3, which is a math constant, the square root of 3, which we know comes from that Vesica Piscis, is the Euler-Mascheroni number. Pretty amazing, right? And nobody ever made those connections before, except for myself and Alan Green in this way. So we made a video of all this. If you're interested in watching that video, it's called Quaternion Symmetry. And we published papers off of this as well. And so the Vesica, in an extended form, creates this larger and larger and larger flower of life that extends infinitely. And then secondly, in the process, it's creating all these nodal points of mathematical constancies and musical notes. And those nodal points are creating specific geometries where those overlaps happen. And that's what we're going to learn about today. Because not only does this apply to the things we've talked about, but it also applies to this. So what is this? This is the periodic wave or spiral of elements using the flower of life to get us there. Now you might remember in school that the periodic table of elements has noble gases. There are different families of gases, right? There's the noble gases, the halogens, the oxygens, the nitrogens, the carbons, the borons, the berylliums, and the lithiums, right, etc. Well, what this is this is a sine cosine wave going outward in a spiral. And so while I've used helium as the first element to show up here, which is right here, at this point you see the letter H, and then it goes from hydrogen, then it goes to helium, then lithium, then beryllium, then boron, then carbon, then nitrogen, then oxygen, then fluorine. Now, the colors that I used here are not just by happenstance. These are actually the spectral analysis colors of these, related to these particular elements that you see. So far, that's basically how I've done it here. And as this goes around in the circle, you'll see that the noble gases, I did not follow that coloring convention totally with the noble gases because they fall into what's called like a dead zone for coloration, even though they do look like neon colors, like you'll see them. Where that's occurring is here, the noble gases are on both sides of this, like so you could say this is mirror reflection. So you have helium here, then helium goes to neon next, then neon goes to argon next. So as you're going down the periodic table of elements, then it goes to krypton, so krypton follows argon, and then it goes to xenon, then it goes to radon. And so then you have all of the noble gases, and this basically aligns perfectly around a circle. Now, if you extend this and realize that this is wave doubling math, there should be 9 elements prior to hydrogen because everything's wave doubling math. And even the octaves, because each of these acts like an octave in the sine cosine wave. So for example, there are 8 elements that sit inside the carbon wave, which is the wave we most think of because that's the one that's got all the stuff related to DNA. And DNA is made up of carbon, nitrogen, hydrogen, and oxygen, and sulfur, and nothing else, right? So basically, that's predominantly 4 of those 4 elements that also represent earth, water, fire, and air. Each of them is represented right inside here in this carbon wave. Well, the next wave is actually going to be on the opposite side. So I would take the next octave up would be the opposite side and 1 circle farther out. And so that's why silicone is right here, Si. So you've got magnesium, right? Silicone here, phosphate, chlorine. As you go around, well, the number of elements that are in the silicone wave is also 8 because it's wave doubling math. So it's 8 elements in the carbon wave, 8 elements in the silicone wave, and then it doubles, right? And then you start getting isotopes coming off of that as well. So that's why there's 17. You've got isotopes that are starting to show up in this wave of elements. So it goes 17 the next one, and then 17 the next one after that. And then you start getting more and more because those isotopes start expressing as what we would call more normalized or stable elements. And so you've got the lanthanides and the canthanides, and the whole table then, if you were to include everything, would actually have 137 total elements based on expansion after wave expansion after wave expansion. And all of this can be found right in here. And there's a legend here even of musical notes, because they're actually musical notes. All of the elements of the periodic table of elements, or the periodic wave of elements, are actually musical notes that correspond to these families, right, within this spirality of nature. And what I wrote here is that there's only one element moving through its periodicity. So you start with hydrogen, but actually I just said there should be 9 elements before hydrogen. That means that there's going to be, hydrogen has 1 electron and 1 proton. That means that there should be hydrinos that have, something at a sub-level even, differentiated from an electron. Or maybe there's just an element that has only an electron or maybe only a proton. These are all outside of our ability to see it. But there's a lot of theory that's been put forward about hydrinos in particular. So this is just the way the families all separate out from the flower of life. And people ask me all the time, why do I need to learn this math? This is or geometry. What does this do for the world? Well, you know what? Actually, if we could understand this fully, we could literally change the world, especially a world that is today very focused on scarcity and lack of abundance, into one that could be literally an age of transmutation, where we could create whatever elements we wanted to, and even new isotopes, new types of carbon-based metals, for example. Walter Russell talked about that. And this is just an expansion using the flower of life to come at the same thing. Now, I took another approach to this, is this one right here. So this is, I did this probably 5-6 years ago now. This is the periodic wave of elements again, but it's shaped like a snake, right? I didn't really intend when I made it to look like a snake. I just knew it was following a wave pattern, and I started out with the elements that were the elements prior to hydrogen, and followed that along, and actually used the name that Walter Russell used on all of these elements, which was a strange coincidence because I'd had a company that I founded called Alpheon, and it had already been in existence before I ever knew who Walter Russell was. And when I saw that the company name almost identically matched with 1 letter difference, the first element of the periodic wave of elements by Walter Russell, or the spiral he made, I was like, whoa, that's weird. So basically what he says is that this is a inhalation, exhalation cycle that happens over and over and over again in the universe, and that the last element on his periodic wave, or his spiral of elements, is omeganon, and the first is alphanon, and they're basically the same element. And it just repeats over and over and over again, and you get to hydrogen, which shows up right here. And hydrogen takes on the form in 3 dimensions of the tetrahedron, and therefore it has a sum of angles of 720 hertz, and in this case, or sum of angles of 720 degrees, excuse me, and if we just make a conversion of that over to musical notes, that would come out to 720 hertz, or beats per second, and what you find is that these wave peaks all become notes in an F-sharp major chord in 5-part harmony. It's fascinating. If you're interested in learning more about that, you can watch a film that I helped, the second one I helped by being the executive producer of it, and it's called Sonic Geometry. You may have seen Sonic Geometry. It's had a couple million views, whatever. I produced the second one with Eric Rankin. And Eric's a great guy. And I saw his first film and I said, wow, we've got to extend this work. And he did the first film without me. Both of them are outstanding. So anyway, I really recommend you go and look at that because it explains how music and chords of music are identical to geometry just by making a simple conversion in their Hertz frequency from their sum of angles, which always sum to the number 9, like 7 plus 2 plus 0 equals 9. So then I started to build this whole thing out based on geometry and every one of the elements of the periodic table all the way around. And sure enough, right, they then have their sum of angles and their Hertz frequency. And then as you get to light, you can basically take it up 45 octaves. There's a lot of people who think that, and it's funny when people want to school me on this because they're like, wait a minute, dude, you can't compare sound waves with light waves. Light waves are transverse waves, and sound waves are longitudinal compression waves. Well, duh, I know that. I've only worked in photonics for 30 years. But the thing is that there is another dimension of understanding that we are missing. Sound is the same thing as light. It's basically the gravitational form that light takes on. And the entire universe is connected by this gravity or this ether, as it was once referred to. And that is also what we call time. And so as we see light will then convert into its gravitational form. There's two sides of light, right? The opposite of light becomes gravity. And so you can think of it as a punch out, right? So you've got this black background, which is all gravity, and then you've got light that comes out of that background. And then it doesn't really travel, it just reflects. And so when it ends up hitting a solid medium, the light gets absorbed, but the gravitation takes over and resonance then rings each of the planets just like a bell. And that's why each planet has a resonance. Each planet is a musical note. It's because all the light that is basically coming into it is making its conversion across Fibonacci numbers to Lucas numbers into sound waves. And photons then transmute into phonons. They just move more slowly. So phonons are traveling at 27 squared, right? So 27 squared in miles per hour. And photons are traveling at 432 squared in miles per second. And that's the conversion. So phonons traveling at 27, well, it's actually the same note. 27 is the note A. You double it, it's 54. You double it again, it's 108. You double it again, it's 216. You double it again, it's 432. So it's the same note. And that's the differential that occurs between compression waves, which are sound and longitudinal, and light waves, which are transverse. And the sound waves are looking like jagged teeth. You know, you could see like a sawtooth graph, right, where you've got these lines that kind of go up and down like this, whereas transverse waves have this nice spirality look to it. So basically what this now includes is all the different Hertz frequencies that would allow us to change matter, we believe, from plasma with electromagnetic caging and sound and light into other elements of the periodic table of elements. So we're very excited. I'm very excited about this. I actually have filed patents on a 4D printer of matter several years ago, and those patents have been received by the Patent and Trademark Office, but they have not been issued yet, so that means they're still in review. But I'm very excited about where this kind of technology can go. So with that, now I'm going to show you something else today, which is going to speak to this incredible order of the universe and just how amazing the order of the universe really is. Okay, so I'm going to use a pen today. So hopefully you guys can see this well. It looks like the people on Instagram can see better today also, which is a relief. So let us go ahead and make our central line marker here. you can tell I've already done a flower of life on this one because I can see all these pinholes from the prior page. I'm going to show you something very interesting today that speaks to this order of the universe. Again, I just laugh whenever someone says to me, oh no, everything's entropic. It's all materialist. It's not that they're wrong. They're right from their own perception, but it might just be a limited perception. Okay, so let me go ahead and measure this. So I'm going to go with 6 inches. It's a pretty big circle. So it'll give me a 6-inch diameter, or sorry, 6-inch radius to draw this circle within. I need to change this pen. This pen is looking a little dry. Yeah, let me do that. This one's better. Now, when I change my pen, I'm going to have to remeasure this again. Looks pretty okay. Okay, so everyone should be able to see that circle. Pretty easy. All right. So now I'm going to take my compass and I'm going to, and I guarantee you, no mathematicians you know this, so you can show this to them and freak them out and all to your heart's content. So I'm going to just do like a flower of life or like a Vesica here, but I'm not really going to do a Vesica. I'm just going to mark over here, right there, with a tiny, tiny little mark. You can see I did this tiny, tiny one over here. Make sure people on Facebook can see this. You can, yep. Okay, so I'm going to take that little mark right there. And now I'm going to draw a vertical line all the way down. So the way I'm going to do that is I'm going to match it up with this line. Right, my horizontal x-axis line. I have not done this in a while, so this will be a fun challenge even for me today. Okay, so now I've drawn a vertical line. I just did it with my pencil. Another one on my rock. Okay. I'll go over with this one. I'm leaving it a mystery. You guys don't know what I'm going to do here. Okay. All right, so now we're going to mark this. We're going to do a little measurement here. Okay. So if I were to then make a line right here where the circle intersects this vertical line. Okay. Now let's see what we can find here. And hopefully it cooperates with us. Yes, it is. So this is from the top here. which would be 0. So let's go ahead and say this is 0, which always angers my trigonometry friends, but because they like to put 0 over here. I don't care. I don't think it really matters. So that means it would be 60 degrees from here, right? Or 30 degrees from here. So since this is 0 and 360 degrees, let's put a 30 degrees right here. Okay, so that's simple, right? Now, what I'm going to do is I'm going to mark each of these points. Now, who can tell me which geometry has, there we go, has 30 degrees as its side relationship to the arc? So how many times does 30 degrees go into 360? That's how you answer that question. 30 degrees goes into 360 12 times, right? So there we go, okay. And that means that it's a dodecagon that we're going to draw to start off with. So now I've got one here, and I'm going to go now from the top and do the same thing. There we go. Just like this. I'm just putting tiny, tiny marks, using my compass to do this. Ugh. I hate when that happens. A little pin goes in, and then I have to make sure that I've got it in the right position again, because it will just minutely change everything. Make sure all your stuff is tight. Okay, we're good. So mark it here again. There we go. So now I've got 12 points. I'm going to connect the dots for those 12 points. Right, so let's just go from here to here. I'll move this down a little bit so I can see this a little better, closer. Okay, there you go. There's one. Now the other way I could have done this is just with Metatron's cube, and I could have done 2 Merkabas, and those 2 Merkabas would be, one would be like a mirror reflection of the other around this Cartesian plane. So I would end up with 12 pointed star. Right, but this is another way to do it, and I'm going to show you why this is significant in a moment. The nice thing about using a compass also is you know you hit the right place when your end of your pen or your pencil falls into the hole that your compass was at. Okay. So I've got this nice dodecagon coming to life. And 12 is such an important number because so much of our lives are dependent on 12 in measurement and in time, right? All of our measurements in music are based on the base 12 numbering system. And time. We have 12 hours that then turns into 24 hours. It's a sine-cosine relationship. You know what's interesting is that if I took a 24-sided polygon, the way I would solve to see how many what the sum of angles of the 24-sided polygon would be is because I know that 12 is 30-degree arc, right, on each of its sides. I could then say, okay, 24 is double that, so it's going to be 15 degrees. Well, 180 degrees, so half the circle, minus 15 degrees is 165. Multiply that by 24, the number of hours we have in a day, and you're going to end up with 3,960 degrees. That's the sum of the interior angles of a 24-sided polygon. Now, that's interesting because it just so happens that we have 24 hours in a day. The Earth spins on its axis in that 24-hour period. And 3,960 is the sum of angled degrees of that 24-sided polygon. Well, 3,960 also is another important number that relates to Earth because it's the exact radius of the Earth in miles, 3,960. It matches perfectly the number of degrees. Look it up. Just Google radius of Earth. It's going to give you a range because sometimes they have ranges on it, but the range will be 657 to 3,961. Anyways, those are the ranges. You'll see it. It's there. But it matches. It's beautiful how much it matches. It's perfect. So we just made this dodecagon now. Now, let's do something else. We're going to now take our compass again, and we're going to take it to the center point of this dodecagon. And we're going to draw inside the center point of the dodecagon. And we're going to inscribe a circle. So you're going to want to make sure you test to make sure that your circle that you're about to draw never goes outside the lines of this dodecagon. And if it doesn't hit it perfectly, don't worry. If it's super close, it's fine. Okay, so now we have an inscribed circle inside this dodecagon, right? And why did I do that? What the heck's the point? What is the point? So now I'm going to draw a line that's going to go from here to here. So from the center out to this next crossover point against our vertical line. So I've not drawn it perfectly, but it's pretty close. Now if I were to measure this, okay, so basically this is giving me now, okay, so 10, 20, 30, 32 degrees. So we're going to mark 32 degrees on there. Okay. And in fact, it's a little bit more than 32 degrees. Let me just do that again. That's right on about 32. Okay. So then we're going to take let's go ahead and find out what is 32 divided by 360. And you know what? Where is my calculator? They're on my phones. I can put it up on my computer. Okay, so we now have 360. Okay, and going to be. It's interesting. So what that is basically pointing us to is it's pointing us to the next level, which is going to be an 11-sided polygon. It's really interesting. Okay, and but we're going to bypass that for a moment, and we're going to go to the next level down, which is actually going to be right here, 36. So now we've got 36 degrees, and we're going to take from this, we're going to move our thing across here. And let's just try this. Actually, another way I could have done that to test this out would have been to go like this and see what happens if I go and marked every one. Right. Take some real concentration sometimes. Right, so that's what I thought. Okay, so now we're going to take this at 36 degrees, going around this circle. Make sure we match up to the 0. We'll mark this just like that, just like we did the 12. Center. Okay, around. There you go. All right, there we go. All right, so now let's draw inside of this. We're going to, oh, you know what? That's what I messed up last time. I knew I forgot something. There we go. That's right. I was supposed to do it on the inside circle. My bad. Yeah, that's what's supposed to happen here. Okay. There we go. I remember when I found this, I was like so mind blown by this. As you can see, it's not exactly easy to remember or even to do everything that you find. Okay. All right. So then, and that goes here, 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 and 36 goes. Yeah, so now it's going to 45, 36. All right, I know what to do. I'm going to do this. draw lines to basically connect the, to make two hexagons inside this as well to kind of help us to orient it. It's going to go to every other one. So you've got just like drawing the Merkaba. So then it's going to go just like this. There we go. Do this. Now I'm going to do the opposite ones. Okay, so now we're going to draw another circle at this point right here. Where those two hexagons overlap. Exactly. Just like that. Okay. Okay. All right. So now we're going to measure, okay, where these, this is now overlapping. All right. So if I had drawn this perfectly, which I did not, then this point right here, where this vertical line overlaps, this line is going to be right on 36 degrees. So right on this spot right here. Okay. Now why is that important? Because that's now going to inform for me the next thing that I can draw. So I'm going to now take the next circle. I'm going to draw it right in the center of the, let's see. Yeah, we're going to go, we just did that. Okay, so now I'm going to go inside there. That's what it is. Just like this. There we go. So now I've just drawn a circle inside these two hexagons that make this dodecagon. So I still have my dodecagon broken into two hexagons, and where this overlaps is right on 36 degrees. So now that's going to inform for me where along this circle, so I'll put it right here. So the only difference is, see this right here, that should have been right tiny bit more there. So now I'm going to take it, whoops, that's a bummer. Take this, and now that's my 36 degrees of arc. I'm going to mark this going around. looks like this. And that works perfectly. Look at that. Beauty. All right. This is working. Right there in the center. Okay. So now I'm going to draw 2 pentagons and do the same thing. So I'm going to link up this pentagon with this pentagon, which will then make a decagon. So I'm just doing every other one. Now you should be able to decipher what's happening here in just a moment. Because 360 divided by 36 is 10. The dodecagon, broken into 2 hexagons, just told me how to exactly draw not only the pentagon inscribed within it, but also the decagon, which would be a 10-sided, 2 pentagons off center from each other, just like I'm drawing right now. I discovered this about 1.5 years ago. I haven't done it since then, so I'd kind of forgotten some of the elements of it, but now I just remembered everything. So look at that. Isn't that amazing? Talk about order in the universe. Holy shit. The universe doesn't mess around. So then I would suppose that if I continue this process, I could actually then predict what the universe is going to tell me next. So it went from 12 to 10 because I basically, the way I did it was I split these 2 hexagons at the point where they were overlapping. I used that point, right? And in that process, it basically informed me where along that line, right, the next point was going to be based on this vertical line coming down. So you don't have to move the vertical line. The vertical line stays fixed, right? And exactly where that point shows up is going to be informing where your next line will be. So now let's do this again. So let's take it to this point right here in between the 2 pentagons. Okay. So the next place is going to be off of this. Let me see here. So it goes, oh yeah, here we go. 45, right. So this, on this next circle, right, 45 degrees, 10, 20, 30, 40. Oh, that's 45 that way, 45 degrees. Yes, so I'm going to mark this. 10, 20, 30, 40. Ah, there it is. Right there. Where this line intersects it. We're at 45 degrees. Against the vertical line, right? It's coming right here where that intersects against the pentagon, right? right, is going to be, so that's what it is, where this pentagonal line right here intersects with the vertical line coming down is telling me 45 degrees. Now, what's 45 degrees? I'm going to take 45 and I'm going to now remember that point, but I'm going to go ahead and draw an inscribed circle. Just like this. There we go. So now, with that inscribed circle, I've got 45 degrees. And what's 360 divided by 45? You guys probably recognize that. It's an octagon. That should be in the center. I'll just get a little bit off here. Wait a second. Okay, that was right on 45, right? Yeah, that's the right place. Okay, so if I were going to draw this to make this fast, I don't want to run out of time. It'll be right there, right? It should be right here. Yep. Okay, and then by the same token, okay, so let's draw the octagon now. So what this is basically showing you is that the universe is telling us exactly where to place our positional points for the next inscribed geometric structure just by using a vertical line coming down. At each point is informing the next geometry. It's kind of mind-blowing, actually, when you think of it like that. Let's see, we can take this one right here. Yep. Right there. So there we go. Now we have an octagon. So we had, starting off with a dodecagon, dodeca, which then took us to a decagon, which was 2 pentagons, so 2 pentagons and 2 hexagons. Then it took us to an octagon, which was basically 2 squares. And I could do the same thing. I would need to do the same thing, right? To make 2 squares out of this, I'd have to basically just cut this across like this so that I could find the next angle measure. Same thing, it's going to give me an offsetting value as well. And then I'm going to basically split those two and see where the reference point is against the vertical line that started at 30 degrees, just straight down. And from that, I can solve all the rest of all the geometries just by following that line straight down. And they'll just continue to inscribe within and inscribe within. So I'm going to go ahead and stop here. Thanks everybody. Great to see everyone. And hope to see you next time. I'll be doing this tomorrow, and I'll do a review of this as well. Thanks so much. Bye.